Space Lab Marshall through Aurora for 4 minutes and 50 seconds.
Okay, Marshall, this is Space Lab. We are running happy.
Okay, we'll stay quiet here for a minute, Ulf.
Okay. I have one report on Madame Rodin. Maybe I can do that whilst I'm running EPI.
Yeah, we'd like you to do that, Ulf, please.
Okay, I was at the position with the big sphere. It was really a nice and fat sphere of low viscosity oil, and I was trying to find the first resonance frequency. As the procedure said, I started with 0.2 Hertz and went from there to 0.3 and then to 0.4. And at 0.4, the amplitude of the sphere was already pretty high, and I was considering to reduce the excitation amplitude when the whole thing spread again over the edge of the attachment plate, in spite of the anti-spreading barrier, and I had to stop and I cleaned it. So my proposal is to do the same thing again, but start with the 3 centimeter sphere instead with the 4 centimeter sphere. It appears to me that the attachment area is just too small, and that means the contact angle is very high and the risk is high that the whole thing spreads over the edge. With the 3 centimeter sphere, it would be much better.
Yeah, we copied that, Ulf, and we concur. 2 minutes and 40 seconds to LOS.
Okay, and my next action before we stop the dome is to stop the IHF. It's blinking here and waiting for the next sample.
Okay, Ulf, that's fine, and be advised we're looking at the downstream activities in the PCAP. Oh, by the way, it's 304. Next sample is 304. And we're also looking at what we might do to ease up your next hour or so while Bob is likely to be away. And we'll get back with you at the next TDRS pass at 1957.
Okay, we'll wait for you.
Columbia, Houston.
Go ahead, over.
Roger, John, we'd like you to delete the 2 water dumps scheduled for 2000 and 2155. We're boiling enough water that those dumps are not required.
That's what I figured. 2000 and 2155.
Roger that, and also 3 teleprinter messages coming up right now. You've got a cap update, changes to the attitude timeline, and entry block data. You'll notice there's quite a few changes to the attitude timeline due to payload requirements for changes.
Is that because the payload's not working or something?
There's been a reshuffling of experiment activities, and you'll see that on the changes in attitudes or the attitude timeline, starting at 3 days, 23 hours.
Okay.
And I'll hand the air-to-ground 1 loop back to the guys in the back.
And hold for LOS in 10 seconds if you got anything for us.
No.
Space Lab Marshall, IOS.
Lost, this is Space Lab.
And Space Lab, Marshall Ops, go ahead, Ulf.
Okay, we are set for the dome. We did happy. We have sample number 304 in the IHF.
Yes, we copy that, Ulf.
Ulf, I think we've got our uplink back. How do you copy?
Okay, stand by. Okay, Marshal Ops, go ahead. Ready to copy.
Okay, got you loud and clear, Ulf.
And Ulf, we have Larry Young on the loop to give you some advices and information for Bob and you on the dome run.
Okay, go ahead. Right now.
Ulf, this is 102. Do you copy? Space Lab for Ulf, this is 102. Do you copy?
Loud and clear, Larry. How are you?
Very good. Nice to speak to you, Ulf. First point, you only need the contact lens in one eye, of course, for video. I prefer the left eye, but choose whichever one you want as long as you remain consistent and tell me what it is.
Okay, we'll do that for you.
Second, Ulf, would you and Bob try to evaluate how well the contact
in
lens
respect to
sticking
the
with distilled water irrigation is working?
That is really a killer. After 6-7 hours, it's causing such a headache, there's no way for me to keep that on all day long.
Right, Roger, you were referring to the ARU, are you, Ulf?
Oh, I had it on now until about half an hour ago, but I have a terrible headache and I took it off.
Ulf, how low are you wearing the strap on your forehead? Can you wear it high and put the CCU unit on to hold the ARU hat on?
Space Lab, for Ulf, will you try to evaluate how well the contact lens will be sticking?
Yeah, okay, I'll do that.
Thank you. Next, I would like you to try to evaluate the outlasting circulavection after you close your eyes during one of the dome runs, as we discussed in training. Do you copy? Space Lab for Ulf, this is 102. I would like you to evaluate the outlasting circulavection after closing your eyes on one dome run. Do you copy?
I copy, but I'm not quite sure whether I understand what you want me to do. The outlasting circulation, that's what I understand, but I don't know what it means.
Ulf, you recall that in the last session at Dryden, I told you that it's possible that after closing your eyes, once you have circulavection in the dome, you may get a continuing circulavection, even once your eyes are closed, in weightlessness, and I wanted you to evaluate that. Over.
Okay, we'll do that.
Thank you. Next, I will want you to comment on the quality of the vection and compare it to ground tests, supine and erect, and compare it to the experience in the KC-135, both for the free float and for the bungee.
Okay.
Next, I would like you to observe whether the feet sway so far as to hit either the floor or the ceiling during the free float runs.
Okay, we'll try it.
And finally, I would like you and Bob to tell me whether there is anything provocative about the dome rotation.
Okay, fine. Now, let me tell you in this connection that the oscillations during the FO2A were provocative, and for that reason we stopped it.
We copied that, Ulf. Thank you.
All right, do you have any questions about the procedure?
Not for the time being. We have everything set up here and should work.
Very good. Go ahead. We'll be listening for your status.
Okay.
And Space Lab, all for Bob, no reply necessary. If you want us to, then we can start the recorder for TV-17 if that makes it easier. And Space Lab, for Marshal Ops, be advised you have 32 minutes in total on AV2 for this run.
Marshal Ops, Columbia, have MCC give me a call, please.
Roger.
Columbia, Houston, go ahead. Columbia, Houston, go ahead, John. Columbia, Houston, go ahead.
Houston, call me over.
Go ahead.
Roger, in that message you sent me, there's no maneuver in the back for 4 hours and 7 minutes, 4 days and 7 minutes, 4 days, 1 hour and 37 minutes, 4 days, 2 hours and 48 minutes, and 4 days and 2 hours and 57 minutes. And so I think part of the teleprompter message must have not made it, over.
Stand by.
I'm saying, Houston, is all the words are written down, but the attitude timeline is not there for those maneuvers.
Columbia, Houston.
Over.
Roger, John, we want to make sure you got all the messages. We've got the cap update message 53 and the attitude timeline message 52. And message 52 is 2 pages.
Okay, I only got page 1 of, I only got page 2 of 2. I didn't get page 1 of 2. That's what I figured.
Roger, we'll retransmit, John, and I'll give air-to-ground 1 back to the Gibbs, and I'll see you on UHF here at Bermuda in a minute or two.
Okay, what had happened is it just sent us a weather, and then it went right to page 2 of 2. It never made it to page 1 of 2.
Okay, that explains the problem you had. Thanks. We'll get that up to you.
I'm clear, Houston.
Space Lab, this is 102. We're receiving good dome data. We would like to confirm that you have started the videotape recorder.
102, go ahead.
Ulf, we are receiving good dome data. We would like to confirm that you have started the videotape recorder.
Show us on the orbital recorder and let me check with John.
Very good. Thank you, Ulf. The data looks beautiful coming down. Thank you.
Okay, the recorder's running, Larry.
Very good, Ulf. Thank you. Can you tell me if you see that he's swinging his legs so far as to hit the floor of the Space Lab?
How we do during nighttime? Are you talking about these flashes?
I wanted to know if the subject is swinging so far that his legs touch the floor of the Space Lab.
No, he's free floating.
Very good. Thank you, Ulf.
And Space Lab, for Ulf, no response required. The data really look good from the dome, and we are taking care of AV2 from here to record everything. Over.
Okay. Do you see Bob now?
Space Lab for Ulf, this is 102. Or for Bob.
Go ahead.
Our display shows that you have MS-1 3200. Are you going to, does that mean you're doing the Parker Dome run with bungees at this time?
Yes, correct.
I understand. Thanks very much. We got beautiful data on that last run.
Okay, we are ready for the next one.
Start recorder.
Nay, do you receive that split screen picture? Oh, that's recorded, okay.
Okay, Space Lab for Ulf. From now on, we're running out of coverage. You have to take care of AV2, and you can go down to time remain of 3 minutes.
Okay, cleared for 39er.
Okay, Space Lab for Ulf, a little correction. In total, you can go down to 2-3 minutes remain. Over.
23 minutes.
Space Lab, this is 102. Space Lab, this is 102. You're getting very good data once again for the bungee runs. It appears as though there's less vection.
Okay, thank you.
And Space Lab 102, you can terminate the tape recorder anytime now.
Okay, we stop it here and we'll take some other data on me now.
Space Lab 102, very good. If when Parker has some time during your run, I'd like him to get on the air and tell me what his sensations were. Space Lab, this is 102. Space Lab, this is Experiment 102.
And Space Lab, this is Marshall Ops. We are with you for 50 minutes. Over.
Okay, PSCC.
Okay, and Bob, if you are ready, we have your 3 points for you. Over. And Space Lab, this is Marshall Ops. If you're ready to copy, we have here several points for you.
Several what?
If you're ready to copy, Bob.
Ask you one question. There's a AO3 update that you guys want me to make, and you asked me to make it for day 5, which would give it a valid time well beyond tomorrow, instead of day 4, which would be valid for approximately now forward for 24 hours.
Stand by, we get it.
Capcom.
1 second. And Space Lab, it's day 4 instead of day 5. Over.
I understand, day 4. Do you guys have you want an update on it?
Columbia, Houston. Columbia, Houston on air to ground 1.
Okay, go ahead, over.
Roger, John, data shows that we're boiling a little bit too much water. We'd like to switch over to FES Bravo and therefore also the Charlie and Delta water tanks. We'd like you to turn FES Pri A off and FES Pri B on, and then we'll continue to watch.
That's done. And maybe just kick right in.
Columbia, Houston, stand by. Columbia, Houston, we see FES Bravo controlling okay now, and we'll let you know when we want you to go back to the original configuration. Problem was we were starting to boil water out of tank A, and we didn't want to do that.
Go. And Space Lab, this is Marshall Ops. If you're ready to copy.
Say again what you need for us to copy there, Fox.
Okay, Bob, the first thing is we have good news on the IHF. We're back to normal scheduled operation, which means that in the next few minutes or so, some of you can start with Foxtrot 616, step 4.1, over.
You want to do procedure 616, step 4.1, correct?
Yeah, that's affirmative, and that will let you to remove the sample number 304 and set the IHF up in the gradient mode, over.
Okay, copy.
And in addition, Bob, I have here a request for experiment 14. For experiment 14, at 22 hours, 26 minutes, we would like you to look at display 14 alpha and look at the displayed values, in particular the film advance asterisks, for which should be there for every 16 seconds. Over.
Okay, it's all garbled, POCC. Give me the time and what we want to be looked at.
The time 22 and 26 minutes. Look at display 14 alpha, film advance asterisks, and other display values.
You want to see if the film's advancing?
Exactly. And then Spacelab Bob, we also have a message here from the D1 project office. Stand by, Capcom needs to loop, over.
Columbia, Houston. Columbia, Houston, air to ground 1. Roger, we see spec 224 water pump message. We think that was caused by the transient when you switched fesses. Very sensitive transducer on that system, and you can ignore that.
Okay, I was planning to ignore it because the same thing happened last time when we did something like that, and that's what they told me the last time too, so I wasn't going to mention it if you didn't.
Okay, John.
It had the same indications on the deuces. It went down to below 300 and something, and then came back up. When it passed 400, the down air went away, and it looked like that's just what caused it.
Roger that. And we'll give the air to ground 1 loop back to the Gibbs.
Okay. Slopes, this is Spacelab.
Go ahead, Ulf.
Okay. Well, I need some input on the IHF. The port 2 lamp unlock is on and the ISO ops lamp is flashing, and we should know what to do now and how to proceed.
Okay, Ulf, just uplinked that to Bob. It's with Foxtrot 616, step 4.1, nominal operation, over.
Is my understanding correct that you want to change over to gradient mode now?
That's affirmative, and that means that we are back to the normal scheduled operation, over.
Okay, roger that. Is there any chance that we can make up for the samples we did not process so far late on the mission?
Yes, Ulf, that's affirmative. There could be a good chance, over. We don't know yet when.
Okay. And then we should tell you that as far as ICE is concerned, we missed one of these manual FOs because we were busy to set up the dome at that moment.
Copy. And Spacelab, Ulf, can you also give me a final report on the dome run, which you did? Over.
Okay, Bob was subject number 1 and I was subject number 2. We both did it with and without bungees, and as far as I'm concerned, my sensations are pretty similar to the sensations in the KC-135. That is to say, as soon as you take the bungees away, I feel pretty much rotating around the axis and the dome stands still.
That sounds really like good data, Ulf. That's really good. I have one last thing, and that's a message for all of you for the STS-9 crew from the D1 project office. Keenest Timele Panitz, Führer and Messerschmitt follow the crew performance with great interest, deepest appreciation and satisfaction. Over.
Okay, thank you. Best regards to them if they call again. That.
Columbia and Space Lab from Houston on air to ground 1.
This is Space Lab. Go ahead, Franklin.
Roger, Space Lab.
Space Lab, go ahead.
We can hear you. How about Columbia? Can you hear?
Loud and clear. We got a 213 row, but I think it's gone away, and I think it's at Route 21, so we know that one too, if it's okay.
Roger, we concur that it's Route 21. You can ignore that. And John, and also guys in the Space Lab, you can press on with what you're doing. I'm just going to talk to you a little bit about the big picture here, and you don't need to write anything down. We've sent a bunch of maneuver changes. We've sent a bunch of maneuver changes for the next several hours to the orbiter crew to accommodate several things. One of them is the AEPI experiment. I think we mentioned to you before that we're going to use the orbiter to point the experiment, and that's probably a majority of those maneuver changes you saw. But we're also going to do some other maneuvers to get some sunrise data for experiment 16. The Marshall Ops have just ginned up a fairly good-sized PCAP change, which we're going to send up at Mila here coming up. And the reason for that sizable change is pretty much the same. A lot of AEPI and experiment 16. Also, there's some material science double rack recovery things in the PCAP change. We've also deleted the IMU Align that's coming up in the next few hours. It was originally scheduled for 4 days, 48 minutes. We have taken that out to allow for more KU band coverage so that we can dump the payload recorder. We'll make up for that with a Star of Opportunity Align on our call. As you know, without the high data rate recorder, not only are we limited to 1 megabit data capability, but we also have lost our voice record capability, and the dumps have to go down on a 1-to-1 rate. Right now, we're putting the finishing touches on a high data rate recorder troubleshooting procedure that Bob and Owen can work on. If, however, we do not get that recorder back, then we and the Marshall folks will be looking at the flight on a shift-by-shift basis to determine how much science will have to be shuffled in order to accommodate the slower payload recorder restrictions. Next, concerning the water and the...
Franklin.
Go ahead.
Go ahead, I thought you were finished.
Okay, I got another minute to go, Wolf. Concerning the hydrogen in the drinking water, we've written a detailed procedure for separating the gas from the water by using the contingency UCDs. If you'd like, we can hold that teleprinter message until you're ready for it when you think you've got too much hydrogen in the water. Otherwise, we'd be glad to send that up as priorities permit. And we're going to lose you here for about 30 seconds while we hand over to Mila, and then I'll be right back. Columbia and Space Lab Houston with you at Mila for about 9 minutes. Okay, correction on one thing I told you. As long as that payload recorder is running, you are getting voice on it. But it's going to be more difficult to count on voice because that payload recorder will run for 15 minutes or so, and then when it stops, you're getting no more voice. Right now, we should have teleprinter messages coming up. For you, John, the attitude timeline, we're resending both pages, and the PCAP changes are coming up for the Space Lab crew. Finally, the weather picture is improving for Edwards. It doesn't look quite as much like rain this weekend. However, the folks out at Edwards tell us that we can't count on the lake beds for nominal use until Sunday. And that's the end of the update. We'd like your recommendation on whether or not you want that teleprinter on how to separate the gas from the water. And other than that, I'll sign off. And Columbia, Houston, John, it's just a matter of your own comfort. We don't think there's anything wrong with drinking the hydrogen. If you think it's going to cause a little bit of discomfort, or if you feel some discomfort from the extra gas, then it's up to you to go ahead and separate the hydrogen as you see fit. Roger that. And John, one last thing. Does anyone on the crew have any comments for us on any of this before we sign off? Roger that. That should be coming up right now.
And Space Lab Marshal Ops, good morning. Space Lab Marshal Ops, how copy?
Clear.
Yeah, Bob, we've got the 01 PI enabled. He's going to need an operation that he wants you to perform on his mark at 22:05, and he'll call you about 30 seconds before then. What it'll be...
ops or automatic ops?
It'll be a manual interrupt of the auto sequence. You might pull your procedure and look at MAL 1.6 on page -8.
Space Lab, this is Marshal Operations with a message for Ulf. Space Lab, this is Marshal Operations with a message for Ulf. Space Lab, this is Marshal Operations with a message for Ulf.
Ulf's not on the line. right now. He's sitting in the chair doing his FO6A stuff.
Oh, okay, fine. This can wait. Thank you, Bob.
You guys about to run to about ready to give us some manual 001 procedure?
That's right, Bob. The procedure is your MAL 1.6, and the PI is enabled for voice comm to you. He'll want that done in less than a minute, and he's going to read you some values and tell you at what time he wants it done.
And MAL 1.6?
That's affirmative, Bob. MAL 1.6, the manual interruptive auto sequences.
We're not doing an auto sequence at the present time. We've just finished doing 3 manuals. That's why I was surprised.
I see. Okay. Well, experiment 1 is coming on the air to ground, and we'll straighten that out with you.
Space Lab, this is experiment 1.
Go ahead. Go ahead.
We have the MAL 1.6 with the data XX equals 16 and YY equals 89, 8-9er.
Understand FO16 modifier 89.
That's affirmative. And Space Lab, could you check our DEP panel status prior to executing that?
Again?
Could you please check our panel status prior to executing that MAL?
We were in auto because the last thing it told us to do was to do the shutdown on, let me find it. Earlier this afternoon you had us doing a MAL 1.9, stand by. Earlier this afternoon you had us doing MAL 1.7 Block 6, which we did 2 of, and then following that we went and did MAL 1.8 to terminate manual ops.
Roger that. We recognize we were in
So
auto.
the current status of the panel, somebody just turned on the spec power, but the current status of the panel was ISO mode auto with all the lights off when we started this thing out.
Okay, stand by just a minute and we'll check with our ground people here.
And Space Lab, we've got some PCAP updates we need to get up for Owen, if he's handy, or Byron.
I think Byron's on, isn't he? Yeah. Hey, Bill. Good morning, Bill. Byron and Owen are in here. Owen doesn't have his headset on yet, but I'm on the loop.
Okay, fine, Owen. At 2240, we'd like to have you do a change out of AV2. And for Byron, after the 325 run that he starts at 22 plus 45, we'd like to have him follow that with a 328 alpha starting at 23 plus 05.
Okay, Bill, I copy that 328 alpha starting at 2305. Wolf wanted to...
Go ahead, Byron.
Okay, Wolf wanted to stay in here a while and try and do some more on Madame Rodot's experiment since he had the same problem I had with liquid kind of bulging all over. That gives him about an hour to work on that, so that may work out okay.
Okay, that's great, and I'm certainly sure that she thanks you very much.
And Byron, we have an update on the experiment 326 run. Wolf was asking for a value of Foxtrot 40. We can supply that value now. That value is 0.3 hertz, and you'll need that when you start step 3.2 of the 326 procedure. If you'll mark that down, 0.3 hertz. Wolf might be able to make use of that.
Yeah, I got that, Mike. 0.3 hertz.
Space Lab XO1.
Roger, we're ready to have you execute that MAL 1.6 now with the data that we gave you.
.89, and I'm going to go to start. Running light is on.
Roger, and we're receiving TM now. Thank you.
TOCC, is this something we should have done this afternoon instead of doing MAL 1.7 Block 6 as we were directed?
Stand by, Bob.
Say the same thing, really.
Right, that's affirmative. When that light goes out, we want to place back into auto mode.
Right. Marshal Ops Space Lab, DS2 for Bill.
Go ahead, Byron.
Roger, Owen, we'd like to know if we can do that analog video 2 tape change out right now. Get ahead of schedule here.
We'd appreciate getting the number on that tape that comes off, Byron.
And that's affirmative, Byron.
Okay, very good. Thanks, Bill. Yep.
And I talked to the Space Lab 2 crew yesterday afternoon. They were watching all your activities from Marshall Space Flight Center, and they really send their best, and they wish they were there.
Okay, well, we appreciate it, and they'll have their turn in the barrel here pretty soon.
If you want it, go.
Columbia, Houston on air to ground 1. Columbia, Houston on air to ground 1.
Houston, Columbia, go ahead.
Roger, good morning, Brewster. We're looking at the data, and we don't like the way the water's boiling out of tanks C and D. We'd like you to deploy the radiators so we can slow that process down a little bit. Reference page 513, Orbit Ops Checklist.
Okay, deploy the reds. I'll get on that.
And
FBOCC, we've got the standby light on again for 001. Does that mean you want me to go and execute, I think it's 1.8?
stand by.
1.8.
Okay, Space Lab, this is Experiment 1. We just want to have you place the mode switch back into auto.
Just put the mode switch to auto and leave it there.
That's affirmative.
Okay, it's in auto and ready.
Thank you.
Hey, Mike, this is Ulf speaking.
Yes, good morning, Ulf. How are you doing?
Yeah, I'm fine. Listen, I'd like to go over Madame Rodot again, but there seems to be some confusion. Byron told me that the resonance frequency for the 40 millimeter sphere is 0.3 hertz. I disagree.
I see, okay. This number was generated, of course, by us on the ground as a suggestion, but we'd be really anxious to see whatever value of F40 that you think is appropriate. Of course, you may have measured the frequency response of the 40 millimeter sphere, and we'd like to know what F40 you got.
Oh, I tried, but the problem is when you come close to the resonance, then the big and heavy sphere detaches from the relatively small support plate, and that was my problem. Then I had an overspill over the edge of the small plate at on the rear side. The reason being the contact angle on that small plate is almost 180 degrees.
Yeah, we got... Go ahead, Ulf.
My proposal is then to try to do the experiment, but with a smaller sphere. We'll start with the 30 millimeter sphere.
That certainly sounds like a reasonable suggestion, Ulf. Do you think you'll be able to get a value for F30, Foxtrot 30, to use for that, or should we try and suggest one here from the ground?
Well, I think the better solution is really to do an experiment and find out whether the theoretical number is the same as the ones determined by experiment. And my basic philosophy is to do it experimentally. If it doesn't millimeter, then let's do it for the 30 millimeter.
Absolutely, Ulf. That's an excellent suggestion. The 300 team agrees. Why don't you do that frequency response test with your 30 millimeter sphere, or indeed whatever size sphere you can come up with, which you can find stably suspended by surface tension.
Okay, and I will then also try to do the damping for that 30 millimeter and 20 millimeter spheres only. If I go to 40 again, then we have the same trouble that the contact angle is then very, very small, and it's the same risk that the material will overspill and wet the whole rear plate.
That's a good suggestion, Ulf. Just a minute. I have a message from 300. And Ulf, there's a suggestion here that it might be a good idea to try recoating the base of the 326 pedestal with the anti-spread material. That may be of some help in keeping the oil drop correctly located.
Okay, that sounds good to me, but it takes an enormous amount of time, and we are running behind schedule anyway, so I'm more in favor of doing it without.
Very good, Ulf. Yes, we agree with that suggestion, so continue as you suggest.
The anti-spreading, by the way, didn't hold it anyway. When I did it with the 40 millimeter, I had it coated, but it did not really work too good, too well.
Yeah, okay, we understand. No joy on the anti-spread substance.
Okay, I end the system, the comm system, back to Byron, and then. Space Lab, DS2
here. Stand by, Space Lab. Comtech needs a loop. Or Capcom needs a loop.
Columbia, Houston, air to ground 1.
Go ahead.
Roger, Brewster. At this time, we'd like to go over to FES A. You can go ahead and take your primary B controller off, primary A controller on, and that'll enable us to protect tanks Charlie and Delta.
Okay, we got enough water in Bravo to support FES A, huh?
That's affirmative, Brewster. And,
Comment from Marsh.
Brewster, we're going to go ahead and hand over to Anna right now, and have a good day.
Okay, thanks very much, Bill. Have a good rest, and we'll see you tomorrow.
Roger, and...
Quick comment for Marshal Ops. A quick comment for Marshal Ops. I'm unable to get a dep ready on the CPAC run.
Copy, Owen. And Space Lab, this is CIC. Owen, O2 is enabled, and we'll just let you talk to him.
CPAC, I'm unable to get a dep ready. The best thing I can think of to do is to toss out the ECAS and start over. Do you have any other suggestions, over?
This is CPAC. That's a very good suggestion, Owen. And please verify that the dep is opt.
Affirmative as it is now.
CPAC copies.
I went through the procedures exactly correct, Roger, as far as I know, and somehow when it came time for dep ready, it just remained in no the whole time, so I don't have any idea what the problem was.
CPAC copies.
Columbia, Houston, air to ground 1.
Go ahead.
Roger, Brewster. At this time, we'd like to go over to FES A. You can go ahead and take your primary B controller off, primary A controller on, and that'll enable us to protect tanks Charlie and Delta.
Okay, we got enough water in Bravo to support FES A, huh?
That's affirmative, Brewster. And,
Comment from Marsh.
Brewster, we're going to go ahead and hand over to Anna right now, and have a good day.
Okay, thanks very much, Bill. Have a good rest, and we'll see you tomorrow.
Roger, and...
Quick comment for Marshal Ops. A quick comment for Marshal Ops. I'm unable to get a dep ready on the CPAC run.
Copy, Owen. And Space Lab, this is CIC. Owen, O2 is enabled, and we'll just let you talk to him.
CPAC, I'm unable to get a dep ready. The best thing I can think of to do is to toss out the ECAS and start over. Do you have any other suggestions, over?
This is CPAC. That's a very good suggestion, Owen. And please verify that the dep is opt. CPAC copies.
I went through the procedures exactly correct, Roger, as far as I know, and somehow when it came time for dep ready, it just remained in no the whole time, so I don't have any idea what the problem was.
CPAC copies.
Space Lab, this is CPAC on air to ground 1 for Owen.
Go ahead.
Could you tell us what's going on? We don't seem to have any data.
I've just dropped the ECAS task as 02 Alpha, and I am reloading to try it again.
Copy. Owen, this is CPAC. We have things rolling down here.
Okay, I'm repeating the same procedure. I'm up to dep ready, and I need about another 30 seconds before I expect to get it. Marshal Ops, Space Lab from PS2. CPAC, I've counted sub timeline Sierra 02 Bravo 02, and it doesn't look like it's going to ever give me dep ready again.
Copy.
We have the IU dep back on. We're just follow the nominal procedures just like before.
Owen, this is CPAC. We don't appear to be communicating with ECAS. At least that's the indication from here. We're looking at it.
Yep.
And Space Lab, this is Marshal Ops. We also have Luigi enabled for this pass, so go to it, Byron.
Okay, Bill, real good. Quick status report. If you're ready, we'll be a few minutes before we're ready to talk to Luigi. We changed out the analog videotape recorder number 2, and it was label number 12, okay?
Thank you very much, Byron. We copy. Label number 12 has just been stowed away.
Roger, and that is the, put in the number 6 tape in the second box. You guys don't need to know about that, really, but...
Okay, the number 6 tape in the second box.
And on the IHF, we have just completed the gradient sample insertion and start at 2310, sample 325, and the IHF is in the gradient ops mode.
Real good, Byron. We're also receiving data now, and 300 operations concurs that they see good data from the GHF and that you have sample 325 in there starting its cooking.
Affirmative, and we're just about to get going on Luigi here when I get my act together. Okay, the CPAC dep is opt, and I still have dep ready no. As you say it, just no communication apparently. Waiting for any suggestions, CPAC.
Space Lab, this is CPAC for Owen. Please bring the ROW down, no op the ROW, and then re-op the ROW.
Stand by on that, Owen.
Okay, fine, and give me the ROW number, please.
Don't do anything on the ROW. Stand by, Owen.
Information, it's ROW 21.
Understand, well, you understand, I'll delay. Marshal Ops, Space Lab, how much AOS time do we have?
Repeat.
Roger, how much AOS time do we have? Wolf would like to know.
Oh, we've got plenty of time, 48 minutes.
Okay, 40.
And Owen, you can go ahead and op ROW 21. Do a NOP.
Yeah, I think you mean to NOP it and then NOP it, then op it. We'll go.
Negative, do an op on it.
Okay, just an op. It already shows op, but I'll do another one. Okay, I've issued another op. Want me to toss out the ECAS and start all over on CPAC? There, of course, will not be time enough to make the T0 time now.
Hey, stand by, Owen.
Space Lab, this is CPAC on air to ground 1 for Owen. Please NOP and then op ROW 21.
Okay, Marshal Ops, agree with that?
Yes, they do.
Deal.
Owen, Owen, you will then probably need to re-op our DEP.
Go. That's all complete, and well, I presume I have to toss out the ECAS tags. Is that right?
Negative, Owen.
Okay, I'm back at the 02 Alpha display and waiting to see if anything happens on dep ready.
Owen, please stand by. We're trying to figure out what to do next. If you have any idea, please let us know.
You're breaking up. And re-opt the dep.
CPAC copies.
Awesome, this is CS1.
Go ahead, Ulf.
Yeah, I'd like to give you a brief report on Madame Rodin, experiment 326.
Yeah, go ahead, Ulf. 300 is ready to copy. How are things going?
Okay, I had to stop you because Byron wants to take over the FPM to run Luigi. I tried the same run with the 30 millimeter sphere, but I had the same trouble, and I give up on it. I think it is probably really the best thing now to re-coat the whole rear plate with anti-spread barrier material, and I will do that now, and hopefully we find the time to rerun Madame Rodin either tomorrow or the day after tomorrow.
And Ulf, we have a question for you from the 102 team. They wonder at what time and what steps you did your ARU change-out. They're very interested in the step numbers that you did so that they can track that and do their planning here.
Yeah, you change out with Bob Parker or with Zoom? Or just battery change out?
The question concerns yourself, Ulf, your own ARU unit.
Okay, I have one cassette which runs since, wait a minute, GMT, 8 hours, 40 minutes, and 35 seconds. And it's time to get a new one in now.
Okay, we copy.
And Tom, Chuck Ullman, that these ARUs are real killers.
Ulf, I have a question from the 102 team now. They want to know what steps of FO6A you ran.
Okay, we did 20 head movements with eyes open, and I quit after that because feels very uncomfortable. And I tried to do the same thing with eyes closed. For comparison, it's a little easier, but it's also not really nice to do. So that is really not the thing to do now, because there are so many other things, and I really don't want to get sick.
Okay, we copy that you did do head movements with your eyes open, and you also did some head movements with your eyes closed, is that right?
The same number. I did 20 eyes open and 20 eyes closed. CPAC from Space Lab, still standing by. No change in dep ready.
Owen, this is CPAC. Could you please confirm that the only switch on is the IU dep at this time?
Okay, Roger, you'll have to repeat again. The FPM just took off and it makes so much noise I couldn't read you. Say again.
Could you please confirm that the IU dep is the only switch on?
That is affirmative.
Owen, they had a hard failure in the ROW, in ROW 21, and so we would like you to safe CPAC at this point to terminate operations.
Okay, I understand it's a failure in Route 21 and to terminate CPAC ops. Is that correct?
That's affirmative, Owen.
Okay, thank you very much. There's a metric camera that just took off running here, and it is extremely noisy.
This is Space Lab.
Go ahead. Go ahead, Space Lab.
Bill, I presume the tape removal and installation at double lot 15, tape recorder number 2 will now not have to be made, so I can toss that out of my timeline, and I'll plan to use the image intensifier on the next night pass, over.
Okay, stand by a second on that. Space Lab, this is Marshall Ops for Owen. Space Lab, Marshall Ops on there to ground, how copy? And Space Lab, Marshall Ops in the blind for Owen. Your call was correct on that AV changeout. It is not required. And Space Lab, Marshall Ops, please acknowledge on the scratch pad line if you can copy us.
Read you loud and clear now, Bill.
Okay. That beats the scratch pad line any day, Owen.
Oh, it had a message for you there. Did you see it?
Roger.
And Owen, we've a message that when the 33 metric camera operations are complete, about 5 minutes from now, you can go ahead and close the outer cover of the SWAA. Wilco, I've got it, and the camera has stopped running now. Did you get Ulf's question about 10 minutes ago? We got one question from Ulf, that is the idea that he suggested of doing a anti-spread barrier recoding of the 326 hardware. Is that what you're referring to? Negative. He was wondering why you were taking pictures of the cloud-covered ocean here with the metric camera. Okay, I didn't copy that question, but I'll get with 33, and I'm sure we'll get an explanation from you. Thanks for repeating the question.
And Owen, we suspect that the problems you had with CPAC, and you probably came up with the same conclusion, are related to Route 21.
Yes, I did get that, and I assume that until you get that straightened out, all further CPAC ops are canceled.
Yeah, we understand. We've got a lot of people that take a hit on this one, so we're working it very hard here on the ground. And we would like to have you NOP Route 21, Owen.
Okay.
Columbia, Houston on air to ground 1. Columbia, Houston. Yeah, Brewster, sorry to bother you. We had an intermittent side tone on that teleprinter transmission, and we want to make sure you got messages 57 and 47 echo.
Yeah, I'm just getting them out right now, Anna, and they look complete.
Okay, thank you, Brewster. If there's any questions, we'll stand by, but we'll turn air to ground 1 back to the Marshall Ops.
Okay, sounds fair.
And Byron, we have Luigi standing by.
Okay, well, have him stand by because I'm just getting the plates in now, the front and rear end plates. The polarizer, the filter that goes over the light source was really a tough one to get in. It was a really tight fit.
Columbia, Houston on air to ground 1. Yeah, Rooster, that last transmission was garbled. Want to make sure that you understand the procedure and that you are go to do that high data rate recorder inspection.
Okay, we think we understand it. Mr. Parker had already done part of the inspection. The procedure is more specific and tells him also to try and turn a roller, so he's heading off to do that right now.
Okay, we copy and signing off there to ground 1.
Okay, fine, thank you.
Columbia, Houston on air to ground 1, your DAP should be Alpha 1.
It's okay now, Anna.
We just saw that as I was talking to you, Brewster.
Yeah, I was talking. Thanks for the reminder.
And Space Lab, this is Marshall Ops, just to advise you that Route 21 problems are being worked, and the experiments that will be taking hits are 1, 2, 5, 8, and any of those that use the horizon sensor.
Hello, Byron? 328?
Hello, Luigi. I was just about to give you a call. I've just got the reservoir installed, and we're just about ready to go.
Okay, did you get the change on procedure?
I got 2 different changes on the reservoir speeds yesterday.
And Space Lab, we do request confirmation that you have closed the SWAA outer cover.
Affirmative.
Thank you.
Hello, Byron? 328?
Roger, 328 TI, Luigi. How do you read?
Okay, can you tell me exactly what step are you at?
Stand by. I'm filling the front plate now. Okay, I'm at step 1.20, Luigi.
Okay, I got you. .28 to Space Lab.
I'll let you go ahead, 328.
Byron, tell me when you are at the check temperature reading, so I'm prepared to check it from the ground too.
Okay, we'll go. Okay, we're just zeroing now and ready to run the leader through the film.
.328 to Space Lab.
I'll let you go, 328.
Byron, let me tell you, if you can listen to me now, before we get LOS, let me tell you, if you do have problems with forming the floating zone because of wetting properties, then get anything you can get, say for instance a drop, and start doing the temperature. Anyhow. Am I clear?
I understand you want to do the temperature, by one. If we have trouble forming a floating zone, you want to do the temperature on a drop. Is that affirmed?
No, what I want to do, if you cannot get the floating zone because of problems, the problems may arise, then just do the temperature with whatever you have.
Yeah, that's what I understood also. Thank you.
Okay.
And I'm ready to take temperature readings now.
Okay.
Okay, I've selected the first reading, and I have a 161500.
Okay, the T1 is rising on the ground too, so it's okay.
The heater's off right now.
Okay, so it should be coming down now.
And Byron, you can extend this current run on 328 by 30 minutes. Just be advised to keep about the same time, about 20 minutes between 328 and 331's operation. You can continue till...
Okay, we copy.
You can continue to 2 plus 40 to 45, somewhere in there.
Okay, Bill. Okay, that's good. We got a good copy, and the 300 systems people, the fluid physics module just did something strange. I hit the zero switch, and it started moving in, and it stopped. I see the problem. Stand by.
328 to Space Lab. 328 to Space Lab.
Okay, go ahead.
Byron, if you are at step 2.1.
We're at step 1.36.
Okay, thank you. 328 to Space Lab.
Go ahead, 328. We've completed step 1.36. All the temperatures look good, and I'm ready to check the heater operation at step 1.37. Over.
Okay, thank you, but tell me when you are at step 2.1, please.
Go. Okay, we started step 1.37, and the heating has started, we hope. And it looks like the numbers are decreasing, so it looks good.
Okay, it's quite all right. It's on the ground. We do get them temperature increase, so the check is all right.
Okay, the heater's coming off now.
328 to Space Lab.
328.
Byron, before LOS comes, let me remind you that 2-1, you should have received a modification for the speed of the reservoir, and you should read now...
Yeah, I got that.
Okay, thanks.
It's 0.280, is that affirmative?
Affirmative.
And Space Lab Marshal Ops, we're going to put the timeline in hold.
Okay, next. And 328, we're ready to start step 2.4 now. Ready to start to grow the zone.
Okay. 328 to Space Lab.
Ed.
Byron, can you describe the cylinder formation, what is going on?
I'll try, I can't see anything yet.
See.
Okay, I see a few bubbles inside the fluid now.
And Space Lab Marshal Ops, it is a master we're putting in a hold, and it is only a pending hold. And we'll see you in...
Okay, copy, Bill.
Okay, we're going to lose you, and we'll see you at about 2 plus 20. And the
Okay, yeah, I can see the cylinder now.
Can you see?
So I see the tracer particles coming out in a jet in the middle, and they are going out to the outside of the...
And we lost you, Byron.
On volts, and I see out of minus. And I see no effect in the polarity.
Yeah, he said he didn't get any 16 though. I don't think so because I think they Wolf was busy doing something else.
Oh.
And Space Lab, this is Marshall Ops. We have you for about 54 minutes.
Okay, Bill, oh, we've got a real wet fluid physics module up here. If we've got the 328 PI, I'd like to speak to him if I could.
He's certainly on the line. Go ahead.
Okay, Luigi, how do you read?
Okay, go on. I read you perfectly well. 328 to Space Lab. 328 to Space Lab. 328 to Space Lab. 328 to Space Lab. Space Lab. 328 to Space Lab.
Go ahead, 328 Space Lab here.
Okay, I'm ready to listen to you.
Okay, how do you read, over?
I read it very well.
Okay, very good. We had the cylindrical zone almost entirely formed, and just near the end, the fluid detached from the feeding end plate and went over the entire front of the front disc, over. It immediately ruptured, and after that, I went ahead and took some pictures of the heating in that ruptured bubble. You could obviously see the fluid tracer motion. Since then, I've been able to reform the zone. I took 100 pictures of the reform, but I stopped the heating short of 600, so I think the film count was about right. I've since rejoined the zone, and I've been trying to get it to the front end plate with little success. I finally stopped with some sort of a nodoid-shaped figure. I don't believe it's quite a catenoid. And there were negative effects of the plus and minus 100 volt potential. There's absolutely no motion of the tracers. I am in the middle now of filming 600 frames of a heat up.
I lost you. 328 to Space Lab. 328 to Space Lab. 328 to Space Lab.
Marshall Ops, Space Lab, how do you read, over?
I can read you now.
Okay, Luigi, how do you read?
Yes, I can read you, Byron.
Okay, very good. Let me give you a quick description of what happened again. What did you copy? Did you get the fact that the cylinder went over the anti-spread barrier and ruptured? And I did not take a picture of it. It happened too rapidly.
Space Lab, this is 328.
328 Space Lab here.
Yeah, I can read you now.
Okay, did you copy that just before I finished the cylinder formation, it went over the anti-spread barrier and the zone ruptured? Copy, over.
I could copy only partially, only the beginning.
Roger, did you copy that the cylinder, which was slightly concave, just prior to the full development of the cylinder, the fluid spread over the feeding end plate anti-spread barrier and then immediately ruptured?
Yeah, I copied. Then what did you do?
Okay. Okay, then I turned the heater on and was able to film some of the fluid motion. The particles were very visible in motion. They started from the surface the cold surface of the bubble on the feeding end plate and went down towards the middle and out across the disc towards the outside circumference of the disc. Over.
Okay.
And I reformed that. I did not take an entire 600 frames, though, because it was steady state. I then reformed the zone and took about 100 frames in cine, so we were about on schedule for the film budget. I have then been slowly trying to work the column out to a reasonable length and have been unable to get the fluid to creep back over the anti-spread barrier and reform to the edges of the feeding end plate.
Okay.
Okay, the contact angle when it went over the anti-spread barrier was less than 90 degrees. It was about 70 to 80 degrees. I now have some sort of a nodoid formed, which is it's concave, and I have about a 50 millimeter separation. There's a large bubble, air bubble in there. How copy?
Okay, I'm copying you.
Okay. I tried the potential, plus and minus 100 volts. There was negative motion. We had no effect of the potential, over.
Okay. Okay, go ahead, keep going.
Okay, then I next started the heater, and I have filmed 600 frames in the program mode of the heat up. And the particles come from the rear end plate, drive towards the center of the feeding end plate, out to the edges, and then back along the outside of the fluid. So it's very much as we had suspected. The Marangoni convection is very highly visible here. It looks like point source propagations from the outside edges of the feeding end plate, over.
Okay, that's a wonderful first. You are the first one to see Marangoni in space.
Roger, it's very clearly visible. I have 600 frames of good pictures of it, and I'm ready to stand by and see what you'd like me to do next, over.
Okay, can you try to make a neck, a shape with a neck, like in step
That's
A?
what I have, right? Shape with a neck right now, that's affirmative.
Okay, now if you have it, then film it as much as you can, and then try to break it in two bubbles and film the break.
Okay, very good. I will not be able to get a convex shape, however, so I have to go to step number 8.11.
Okay, fine with me. Go 8.11. That's very great.
Okay, very good. I'm going to break it by stretching here at constant volume.
Excellent. Wonderful, Byron.
I must say, however, though, that there's something strange with the fluid physics module. I have settings now of the front plate at 49.6 and the reservoir at 47.1, but I have a huge amount of fluid in here, so somewhere the machine is not behaving correctly, but I think I can make it do what I want, over.
Okay, fine with me. I mean, as long as you can control it, that's fine with me.
The camera, I've got to try and anticipate a little better. I just missed the breakage here. The camera takes a second or two before it starts, and by that time it's too late, so I'm going to reform and try again here.
Okay, go ahead.
Space Lab, this is Marshal Operations for Byron, if you're not at a critical point in the FTM.
Okay, go ahead, Mike. I'll stop right here.
Yeah, thanks, Byron. I wonder if I could interrupt your work with Luigi to take care of a few keystrokes on the CCO. We have a workaround on the GHF stop, which was reported earlier, and it should only take you a moment. I'm sorry, on the IHF stop 1-12 in the gradient mode. You presently have sample...
Okay, very good.
You presently have sample number 325 installed, and you have the gradient ops lamp flashing.
Affirmative, and I have both port unlock lights on.
That's right. And also on line 3, Lima, you should show that a number 2 is appearing, showing there, which means that the cooling chamber is on port 2. Is that right?
Affirmative.
Okay, what we want you to do is first to turn the furnace over, and then second to get a restart of this very same sample, number 325. The keystrokes you'll need right now are DIN IHF 0000, enter, and again DIN IHF 0000, enter, and resume IHF, enter. Can you do that now, please?
That's complete, Mike.
Thank you very much, Byron. You can return to FPM Ops, but in the next 5 minutes or so, you should notice that the furnace will have returned to position 1. And when it gets there, what we'd like you to do is to do steps 6.23 and 6.24 of the gradient mode checklist. That's page 600-20. That'll get this this IHF sample started again. We're going to rerun sample number 325.
Okay, I got a copy on that. Wilco.
Thank you very much. Back to you, Luigi.
Okay.
Thank you.
Okay, Luigi, we're back on here. I'm just about to reform the zone here.
Okay, thank you.
Remain in the neck without the visualization lamp. Okay, I'm taking 200 pictures now of the zone reforming.
Very good, Byron. And Byron, are you listening to me?
Go ahead.
Okay, so as I said, I would like to also have, films as much as you can, the decay of the temperature in the 2 drops.
Okay, I'm going to try and get another breakage here. I'm now taking pictures of the stretching of the zone.
Okay.
Looks like we now spread over both end plates. It doesn't take very long for the flow pattern to reassert itself here, Luigi. Okay, we're able to film that breakage. There's one satellite shot. And the problem is it's very difficult to see the traces because of the angle of the now on the camera. I'll go ahead and stop the camera now.
Space Lab, this is 328.
You go ahead.
Can you give me exactly the step where you are at?
Yes, I am at step 8.17 now. I'm sorry, I'm 8.19. I have 2 drops. Problem is the drops are so spread out that it is impossible to see any tracer motion with the camera, so I've stopped the camera.
Okay, Ted. To, join the... have to hurry up to give room to Dodo, so try to join up the 2 drops. The reforming of the bridge.
Okay, Wilco.
And then when you have done that, you can, end my experiment.
Okay, very good, Wilco. Well, I'm sorry about I'm not sure what's causing this, Luigi. The fluid doesn't want to seem to stay attached to the edges here. It just gets too much and jumps right over the anti-spread barrier, over.
Even in the, if you try to, if I understood you properly, now you have 2 drops, but they don't, they go over the anti-spread barrier. Is that right?
Affirmative.
Okay, well, just try to put them together and to rejoin.
No.
Space Lab, this is 328.
Go ahead.
Byron, you can start turning the heater off because, you know, Isidoro is after me and is already late and he's right.
Okay. Yeah, I just filmed the rejoin here. I'm really confused. My data out reading showed the front plate at 19.5 and my reservoir at 23.6, but I've got a huge bunch of fluid in here, so I'm not sure I really understand those readings anymore. That seems like a physical impossibility.
Space Lab, this is 328.
You go ahead.
Okay, Byron, whatever you have done with my experiment is about time that you stop it, and I give room to Ignacio. Oh, Isidoro.
Hey, I'm in the process of cleaning up now.
Okay, thank you very much, and thanks for what you have done. It's an excellent job.
Sure, but I did the best I could.
And your best was very good. Space Lab, this is 328.
You go ahead.
Byron, when you have finished, could you give me your readings on the frames are still available on camera A and camera B?
Okay, well, I didn't take any on camera A. And I'll try and do my best to reconstruct how many I think are left on camera B in just a few minutes here. Let me just get cleaned up.
Okay.
And Byron, we need a confirmation that you have closed the SWA.
No, it's the third time you've asked for that. That beauty's been closed for, closed since 2335.
Copy.
Space Lab, this is Marshal Operations for Byron. If you're near the IHF, we need some keystrokes on the CCO. We need a start IHF 2, enter.
Okay. Say start IHF 2, enter.
That's an affirm. Start IHF 2, enter.
Complete.
Thank you very much.
Okay. Now you want to wait till I get a grad op splicing light and a port 1 unlock and do step 6.23 and 24, is that right?
Stand by. We're looking at the data right now. Thank you, Byron. Just a minute. I'll be back to you. Yes, Byron, that's correct, provided that the cooling chamber does go to position 1. That is to say that the line 3 Lima indication goes to a 1. If it stays at a 2, then you're going to have to do the 4 zeros and the 4 zeros in order to make it turn over.
Mike, you want that 6 sample number selected for HTT now, is that correct?
Stand by and we'll check on the HTT progress. I'll be right back with you.
Got a flagging up flight.
Yes, Owen, that'll be the 6th sample, which is number 202.
Roger. Better booster. And space out for the cleaner systems people.
Yeah, go ahead, Byron. 300 is listening in.
Okay, Mike, I need a little bit of help here with the fluid physics module.
Okay.
I've got a very strange situation here. I've got, I don't know, maybe 2 centimeters column of fluid sitting in there at about, I don't know, 7 centimeter diameter. And I'm having trouble getting the rest of the fluid back in the reservoir.
That sounds like a reasonable amount of fluid, like a pretty large amount of fluid. At this point, Isidoro would probably go get his gravy slurper and pull it out of there. What are your reservoir and front plate settings?
Well, they're 13.1 and 13.5 now.
I see. The reservoir is pretty much back to the starting volume. That is to say, it's pretty much full. Is that right?
Oh yeah, that's it, and I tried to manually suck it back in, but I've hit the end stop of the reservoir.
Yeah. Do you suspect there's a bubble of air inside the reservoir?
Well, that's what I suspect. I'm not sure how it got there, though.
Yeah, strange. Okay. Look, let me go with 300, and we'll dream something up that'll get that oil out of there for you. Stand by.
Okay.
Okay, Space Lab, this is Marshal Ops for Byron. The 300 team recommends the obvious move of opening the chamber and going in there with a handful of dry wipes and absorbing the remaining oil into the wipes. You'll also need a plastic Ziploc bag into which to put the saturated wipes when you're done. And both of those items you ought to be able to find in the FPM stowage drawer, which I believe is one of the overhead lockers.
I got him.
Okay,
here we go.
And Space Lab, this is Marshal Ops. We're curious how Owen's work on the HDRR is coming along.
Yeah, I just talked to Brewster about that. He said there's the IFM stuff is supposed to come up on the teleprinter.
Okay, fine. Yeah, there is a message that should be there anytime involving this HDRR maintenance operation.
And Space Lab, be advised, we're putting the master timeline in hold again, and we will recount it.
Okay.
And Space Lab Marshal Ops, there's an AV change out of recorder number 1 at 1:30. Just ignore that.
Okay, I was about to come to the same conclusion. I was just looking at VTR. Marshal Ops, I'm just relaying for Byron. He thinks there's about 1,700 frames used on camera Bravo and nothing used on camera Alpha.
Roger, we copy that. 1,700 on Alpha.
Negative, just the opposite. 1,700 on Bravo, nothing on Alpha.
It's a slow morning, Owen.
Okay, we've got the fluid physics module cleaned up. I'm ready to change plates now, Bill and Michael, and I guess I'd like to know, is there anything they want to do about this reservoir? Should I try and inject some fluid in and see what that bubble is, or what?
Good question, Byron. I suspect there's probably an air bubble in it. Otherwise, I don't know where that oil came from that didn't subtract right. Let me check with 300.
Okay.
Byron, the FPM people say, why not just press on with nominal ops and just, how do you say, proceed with that reservoir regarding it as a full one?
Will do.
Byron, this is 331 PI.
Oh, go ahead, Isidoro. Hello.
Hello, well, I have some minor changes in the page 331A10 of my procedures.
Okay, stand by a minute, okay? I'm just getting the end plates in now.
Columbia, Houston on air to ground 1. Turning flight on.
Go ahead, Anna.
Yeah, Brewster, we have a change on your attitude maneuver at 4 slant 0157 per the park request if you're ready to copy.
Go ahead.
Okay, what we'd like you to do is change the Omicron from 20. It was 180.
Okay, it was 180 and is now, say again?
0.
Breaking up, Anna. Try it again, please.
0.
0?
That's affirmative, Brewster. We want to change it to an Omicron of 0.
Okay, gotcha. So it'll be track target 2, body vector 2, 180, 0.
That's affirmative, Brewster. And we're signing off air to ground 1.
Okay, I got the change.
Marshal Ops, Space Lab.
Yes, go ahead, Byron.
Okay, Bill, quick question for the MSTR people. I don't think anybody but Louis...
We lost you, Byron. Okay, Byron, we lost you. Please repeat.
Roger, Marshal. Would like to know if I can leave film, magazine, and camera A in the fluid physics module. I believe Luigi is the only person that uses that camera. Is that correct? Over.
Stand by. And we're working at Byron. We'll get back to you before this pass on that question, and we'll see you again at Hawaii at about 2 plus 22, and we have you for about another 45 seconds.
I'm going to leave it in then. I don't think Isidore uses it.
Okay, we copy. And Space Lab Marshal Ops, we have you through Hawaii for about 2 plus 30.
Okay, Bill, we got you. How do you read?
We copy you solid, Byron.
Bill, I noticed from the attitude changes that the flight deck has that you're going to an API attitude next night. None of the changes that I've got up here show us to be activating API or running API at the next night. Should we have received an update to run API? Over.
It's in work. We do have an API run starting at 2 plus 57, Owen.
Yeah, I don't think you sent us up anything about it yet, have you?
Yeah, this should be in the regular PCAP.
Okay.
And Owen, if everything goes fine on that high data rate recorder, we'd like to have you do that API run. And we have some notes that we're going to pass up from Dr. Mendy as soon as they're approved.
Yeah, I see it's over in the PS column, so it isn't our standard flight plan, and I still haven't got the teleprompter for the IFM on the HPRR.
Okay, well, hold on that one. We'll get back with you on that.
Hey, Marshall, PS2 here.
Repeat.
Roger, Bill. I'm calling the 300 people. The first time we tried to grow Isidora's zone, used numbers, and the nice ball came out, and it was getting bigger and bigger and bigger, and it never made contact with the other end plate. It just ruptured, or not ruptured, but it spilled all over the anti-spread barrier. Over.
Okay, Byron, we have such a short pass here. We'll be back with you in about 3 minutes through S-band. I do want to get some traffic up to Owen, though. At 2 plus 40, we want you to do an op on Route 21. And at 2 plus 52, we want you to do a NOP. That's Nancy Oscar Papa on Route 21. We need those times pretty close.
Understand, and I'll do it, Bill.
Okay, and we'll be back with you in about 3 minutes on S-band.
I need to know how to use Taday's anti-spread compound.
Space Lab, Marshal Ops, we have you for about 52 minutes.
Okay, Bill. And I don't know if you caught my last transmission. I'd like to get some guidance on how to use John Taday's anti-spread compound. We'll give that a try again.
Roger, we copy. You need some help on the anti-spread compound. And Owen, what was your question on the IHF furnace?
I have a question.
Oh, your in-flight maintenance procedure. Sorry.
Oh, that's right. I was expecting to get some IFM up on the HDRR, but you answered that by telling me they're going to crash on the ground without that.
Okay, Roger, we copy. And Byron, you have a go on 328 operations until 256, and then if Owen is open, other words, if Owen can perform the AEPI operations that start at 2 plus 58, you can continue your operation on 328 until 3 plus 35.
Fine, Bill. I'll run happy. Sounds good, Bill. I'm just getting my hands wet now.
Okay, good, and the PI is enabled on 300.
Hey, I'm standing by to find out how to use John Taday's little anti-spread compound here. Oh, 331 PI, is it go? You down there?
I copy. Clear. I have some instructions for you. Well, first, clean everything. Don't apply anti-spread barrier and proceed from point O to a new point A that should be at 12.5 millimeters of separation. Did you copy?
Roger, copied. Go to separate to 12.5 millimeters. Well, here's what I did. After it didn't work the first time, I cleaned it up, started again. I proceeded back to 22.5, formed a small bubble, and then drove into contact, and then manipulated the speed switches to start bringing it out with a slightly concave cylinder. And as I came out to about a 10 to 12, 20 millimeter separation of the plates, the fluid jumped over the rear plate again, even though it was a concave cylinder. Over.
And Space Lab, be advised, we have live TV from the orbiter.
And Space Lab, this is Marshal Ops. I have a couple of messages from Owen from the 03 team. When I can get them up, I'd like to tell them what we have planned for the next couple of nights.
Ready to copy, Mike.
And Space Lab, this is Marshal Ops. We're getting some excellent live video showing Space Lab and the Earth rolling by below.
It sure is beautiful out there, you're not kidding. Go ahead with the traffic, Mike.
Yes, Owen, we've been talking with Steve Mendy, and well, here's his recommendations for the next 2 nighttime passes. At about 3 hours, what Steve would like you to do is to take the handheld image intensifier to the aft viewport of Space Lab, or the aft orbiter viewport, whichever gives you the best view, and take some pictures of the air glow layer using the diffraction grating. He suggests putting the grating parallel to the air glow layer. This is instead of running Experiment 3, which for the time being is required to operate in the locks, and so we're not going to be running that this upcoming night. This CPAC run at the same time has been deleted. On the following night, starting about 4.5 hours of day 4, what we will be running Experiment 2.0, that's the ESA experiment, with electrons. And what Steve Mendy would like you to do, you or Byron, is to use the handheld intensifier again with no filters at all, and to use the overhead viewport of the aft flight deck area and take some pictures in the -z direction, searching for some fluorescence which might be produced by Experiment 20. Mike, I understand all that. Now, for the first step, I've already made photos like that with the diffraction grading on the image intensifier. The attitude was not always optimum, so if the attitude is better here at 3 hours, it might give me a better chance out at the aft viewport, so I'll take some more of them. As far as the pass at 4:30 is concerned, I may be able to do that at the back viewport better. It's a lot easier to get at, and I have a better, greater ability to move my camera around. With the metric camera up there right beside that overhead viewport, it's difficult to really point it to where we would like to. So I think it might be better for me to use the aft viewport for the photographs at 4+30. Over.
Right, Owen, thank you very much. We copy that, and we'll leave that to your discretion, whichever you think is going to give you the better view.
Okay, I was thinking about getting some H-alpha filter photographs with PicTab. Are they going to have the proton beam on?
Let me check. I don't believe they will. Just a minute. Okay, they will not be running any ions from PicTab. It'll just be an electron run.
Okay, fine. I'll just use the open intensifier.
Real good. Thanks a lot, Owen.
Marshal Officer, Space PS2.
Go ahead, Byron.
Okay, Bill, while you guys, Luigi or Isidore is thinking about it, I have an observation for all of the fluid physics module investigators, and that is I'm looking at the feeding end plate, and there is almost a donut-shaped annulus of liquid on there. It's right to the edge of the 40 millimeter, but right at the hole of the feeding end, liquid is pulled into the edges of the feeding hole. Okay, so it looks like a donut, hole of the donut, right by the hole where you stuck the liquid in. And that could explain why I got liquid back there before, because why I got air in the reservoir earlier, because from a side view it looks like there's a plenty thick column of liquid on the order of 2 to 3 millimeters thick, where in reality that hole is open to air. Over.
Okay, Byron, we copy that you get a sort of toroidal distribution of liquid around the inlet-outlet hole of the feeding plate. That's very curious.
Right.
And Space Lab, we lost our video, but the pictures were really great.
That's good. We're glad you're enjoying them. If Isidore is around and available, I'd like to know how you'd like me to proceed. I've already tried to establish it twice. I think we need some more anti-spread on here, but I'm not sure. I'd defer to his judgment. Over.
Real good, Byron. Isidore is listening in and is thinking it over. He, in fact, is now live air to ground, so he'll be back to you as soon as he has a suggestion.
I don't
Okay.
think you read me.
HDRR is on here. It's a great clip.
Repeat, Owen.
HDRR is running at a great clip.
Oh, that's tremendous.
And martial ops from the 300 people had turned around, and the cooling chamber was in port 1, and I now have an IHF stop, which I'm about to display. Over.
Yeah, 300 copies that, Byron.
Okay, Bill, it's a stop 110, 110.
Roger, copy 110.
Okay, and Marshall, I looked it up, and it says the sample temp is high, and it wants me to restart, and I'm not sure exactly what they want me to go ahead and do a start IHF 2 enter and data in and all that jazz.
Byron, stand by 1 second. 300's checking into that.
Byron, 331 PI.
Space 5 here, go ahead.
Byron, 331 PI, can you hear me?
QEG loud and clear, over, go ahead. Isidore.
Okay, I'll tell you what my thoughts are. You should concentrate on page 10 of my procedures and give top priority to form a cylindrical bridge without any overspilling beyond the disc edges. So I think the best procedure to achieve this aim is to reduce point A, that now stands for 22.5 millimeters, or to reduce it to 12.5 millimeters, and then inject a small drop of liquid, and then get in contact and establish a short cylindrical zone. But please, let's say, forget about the whole experiment and concentrate on page 10.
Okay, Roger, I copy that. And I'm going to take a picture or two of this toroidal zone here for you all to look at.
Space Lab, this is Marshal Operations for Owen, if you're handy.
I'm just about to opt that route.
Yeah, we
The route is opted. Got a route skip 21 message.
Roger, we copy that on.
Also have the PCMMU 00 message.
Yeah, we copy.
Houston Space Lab, did you copy that, the PCMMU message?
Yes, Owen, we see PCMMU 00 message there.
Okay, I was just checking to make sure the Moker got it also.
Good idea.
Oh, and I advised them that that message did come up.
Okay, they're going to take a look at it?
That's affirmative.
And Space Lab, this is Marshal Ops for either of you when you have a minute. We need the two dummy connectors installed on the ends of the IHF thermocouple cables, and we need a start IHF-2 enter whenever convenient.
Okay, Mike, I got it.
Thank you.
Okay, Marshal Ops, the start IHF-2 enter has been given.
Real good, Byron. We copy. The start IHF-2 enter has been given. By the way, is Owen still handy? We have another message from him, for him.
Okay, stand by 1 second here. He's taking a picture for me.
Standing by.
Ready to copy?
Yes, Owen. The 03 team thought it'd be useful if you knew the attitudes for the forthcoming two nighttime passes. On the one that's coming up right away, you'll be in a minus Y nadir attitude. That may be of some help in getting your line of sight positioned out of the viewport. And on the second night pass, the one that's about 4 days, 4.5 hours, you'll be in an ESA 20 attitude with the minus Z axis oriented towards the B direction downward. That is to say, if you get it to the aft flight deck and look up through the overhead windows, you should be looking right along the magnetic field line towards the Earth.
Okay, thank you. Just for information, it's very difficult to use the image intensifier from the flight deck because we don't have any hoods erected there, and it is so sensitive to light that any sort of reflections inside will, I'm afraid, wash out the pictures, but we'll try to pick the best window.
Real good. Thanks a lot, Owen.
Space Lab Houston on air to ground 1.
Head Anna.
Yeah, Owen, in regards to your question on that PCMMU 00 message, we think that was due to a transient due to your route op, and we think the PCMMU interface is healthy.
I understand the transient, but I missed the last part. It'll take care of itself?
Yes, it did, and the PCMMU interface looks good.
Good. Thank you very much. That's some good news. Okay, Marshal Ops from the Space Lab for the MSTR people, 321PI. Isidoro, if you're listening, we've got the plates reinstalled and we're re-zeroing now, so we'll attempt to go to point alpha and start to grow cylinder here shortly.
Copy.
Space Lab, this is Marshal Ops for Byron. I'm afraid I didn't copy that last transmission. Could you repeat, please?
Okay, Mike, just informing you guys that I've started up the STM again. I cleaned the plates off, reinstalled them, and
We're now zeroing the STM and we'll be going to a new point alpha here at 12.5 millimeters. Okay, copies. You got it all cleaned up and got it restarted. Byron, we've just got a message from our ops controller that the 02 team would like you, when you get to this nighttime attitude at about 3 hours, to do MTV manual mode operations. There's a procedure on page detail 18 and detail 19 of the CPAC book. They want you to look around for natural auroras and air glow phenomena in a manual mode. Up until that time, you're go for FPM ops. Okay, we copy. Get some RAL skips and IO messages, guys.
Yeah, we're copying all those messages, Byron, and we're looking at them. And Owen, we need an enter on your keyboard for that RAL.
Sure, guys, waiting until 52 minutes.
Okay, well, you can go now.
And Space Lab, this is Marshall Ops with 2 messages for Byron. Go ahead. Yes, we have a message from the 300 Furnace people. They'd like you, when convenient, whenever the gradient ops light starts flashing, to remove both the dummies that are presently on the IHF cables and plug them onto the real IHF connectors, and then start the sample that's in there, number 325, with the 2 DIN statements and the resume. Okay, we copy that. The other message is from the CPAC people. They want you to be sure and shut down MTV manual ops at or before sunrise, which they figure will be about 3 hours, 18 minutes. Okay, copy that too. Thanks a lot, Byron. If you guys are still on the loop for Isidoro, I've finally been able to get a cylindrical zone here. Hey, that's terrific news. A cylindrical zone. Any bubbles in it, or is it good clear oil? It looks pretty clear oil. The traces look good. I filmed a little bit of the cine filming of it, and it's 12 millimeters long. I'm going to try and stretch it some more. Here goes nothing. Okay. Do you guys have a handy gouge for the reservoir and plate speeds here? I've forgotten them. Stand by. We're checking with the 300 people. They're as excited as we are here in the front room. This is terrific. Let me read you out the front plate position is 12.4. The reservoir is 8.4 right now. It's about 1 to 1.5, but I'm not sure. One for the reservoir and 1.5 for the front plate.
Byron, 331 PI.
Go ahead, loud and clear. Loud and clear, 321, go ahead from Space Lab, over.
Byron, 331.
Let's go ahead.
If I well understood, you asked me about the reservoir speed. Is that right?
Roger, I think I want a ratio of about 1 on the reservoir speed to 1.5 on the 0.5 on the front plate.
But are you in point 2.2?
I'm not doing a step right now, Isidore. I'm just trying to grow a zone here by keeping it by eyeball. Try to get out to 22.5 and 17.6. That sounds good.
Sorry, I cannot understand. Please tell me, in what step are you?
We're trying to grow my cylinder now to step 2.2. You're right.
Okay, then to reach 2.2 step, then you only need to set the reservoir speed, because the front plate speed doesn't move. And then for the reservoir speed, you just set 0.1 millimeter per second.
The problem is that, remember, my front plate was at 12.5 before I got to 22.5. Okay, I'm getting there slowly. There it goes again. 15, I had a nice cylinder, and at 15.2 millimeters on separation, the fluid jumped off of the rear end plate and is just sort of all over the compound. I'm going to leave it here for now and get out and do some CPAC MTV, Mike.
And Space Lab, be advised, we have both the O3 and the O2 PI on the line, so they're waiting for your call.
Okay, good, and looks like all the data is missing from the MTV temperature, so I'll go ahead and assume it's okay and start it up.
Yes, Byron, that's right. We have an inoperative RAL at the moment, so you should just ignore all those missing data.
Byron, 331 PI.
Stand by 300.
Isidore, I'm going to be running another experiment for a few minutes here, so I'll get back to you in a little while, okay?
Copy.
Space Lab, this is CPAC on Air to Ground 1. How do you copy?
Roger, reach loud and clear. This is Bill, Roger.
This is Bill, Byron. How are you doing on D?
Hey, Bill, I got you.
Say again?
Roger, we reach you loud and clear. I've got the MTV up, and I've got a nice view of the limb and the Earth, and we've seen some lightning down there, but no auroral activity yet.
Can you see the lightning in the MTV?
Affirmative.
That sounds interesting. I assume that there's probably no glow available, Byron, because we put the orbiter in a position so that the velocity vector was away from the base, so probably don't need to look for any vehicle glow.
I hadn't noticed any out the rear viewport either, Bill.
Space Lab and Columbia on Air to Ground 1.
Space Lab here. Columbia, go ahead.
Yeah, we have some good news from you. Inco's just finished checking out the high data rate recorder, and everything looks good, and we're back in operation with it. We want to give Bob a attaboy for that.
As he wakes up, we'll do that. You bet.
Okay, signing off Air to Ground 1.
Okay, thank you, Anna. That's news.
This is experiment 3 to Owen. Did you get the setup ready for the camera operation, and how do things look?
That's your call, Steve.
Yes, this is experiment 3. How do you copy?
Okay, loud and clear, Steve, and I'm in the overhead window in Space Lab now, and I've got some fairly good images out the overhead window of the air globe, but it's also in kind of a bluish horizon. It's not really a dark horizon that we're looking at out the overhead window.
That's great. I think what we would like to do is to take a spectra of the sunlit horizon, if possible, with the grating parallel to the horizon.
if you could do that. If you are in the overhead window, that would be an ideal condition for the forthcoming ESA 20 run 2.
Okay, Steve, that's where I'm at.
Space Lab, this is CPAC on Air to Ground 1 for Byron. Would you please scan the limb?
Scan, please.
Say again, Byron.
Roger, we're scanning the limb. All I see is a lot of lightning down there now.
Do you see any air glow?
Yep, sure do.
If you could scan along the limb from side to side slowly, we would appreciate it.
Oh. And my fault, how much time do I have on the tape recorder here? Tape recorder number 1.
We're looking at it.
Okay, I've got some good pictures now. The sun's going down to the air glow, and got a little bit of the the forward part of the orbiter in the view too.
Okay, and Byron, we will turn that recorder off automatically.
Okay, very good. Time do I have there, just in case I want to stop it and then restart it?
You have plenty of time.
Okay, that's good news. Amazing amount of lightning down there. And CPAC from the PS2?
Yes, Byron.
Yeah, we're still getting quite a bit of glow from the sun over the horizon here. It's pretty tough to scan it. I've got to stay pretty much aligned with the nose of the orbiter here.
CPAC copies.
And Byron, you have 19 minutes of fat on those tapes.
Okay, yeah, it looks like we're losing it now.
This is experiment 3 to Owen. How do you copy? This is experiment 3 to Owen. If you got enough pictures with the grating, you might want to change some filters.
Go ahead, Steve.
The filter sequence we have set would be 7620, then 7319, and 5896. These are the first three.
Space Lab, this is Marshall Operations with a question for anyone. We noticed that you seem to have the AEPI video signal routed to both. No, I'm sorry, I'm wrong. It just changed. Are you guys running AEPI?
No, running MTV on CPAC.
Right, that's what I thought. Okay. I see a peculiar routing. I guess we'll handle that from here.
Well, the routing was MTV item 4 to 1, which is tape recorder 1, which just went into standby.
Okay, we saw that, and that looked good, but we don't see that now.
Well, I don't either.
It just changed.
To bed here. It's getting light.
Space Lab, this is CPAC on headed ground 1 for Byron.
All right, you go ahead, Bill.
Are you still seeing lightning, Byron?
Negative, not anymore. In fact, I'm not sure what the configuration of the VAST is right now. The tape recorder went to standby on me, so recording, I'm just looking around. I don't see any more activity now.
Okay, Byron, I would suggest to you that just go ahead and terminate the operations with step 4 of Delta Tango-18.
That sounds good. And Byron, we noticed that VTR number 2 is still recording for some reason. We'll have to figure that out later.
Yeah, well, I don't know what's going on, too. I'll take...
CPAC copies.
Oh, I see.
Byron, when you were seeing the lightning flashes, how many would you estimate you were seeing per minute? Per second?
Right, I would say occasionally times when you'd see 2 or 3 or 4 within a couple of seconds.
Before we had satellites and when we were observing lightning from satellites, the estimate by the learned gentleman in the lightning profession was that the average lightning stroke rate over the whole Earth was 1 per second. But now that we've had satellites up, we can see that that's been exceeded by 2 or 3 orders of magnitude occasionally.
I was going to say, he's too wrong. Okay, we've got the MTV stowed, and I've got the iris shot sensitivities are down. I'm going to go inhibit it and turn it back to auto.
Thanks for this impromptu help.
Turn it back off. I think we got a couple of good minutes of the limb with the air glow and lightning below it and some pressure firings off the orbiter together, so there'll be at least some interesting shots.
So it does sound interesting. Thank you.
Abby, did you have another question or comment for me?
Yes, if the horizon is complete darkness, it would be a good idea to take some more grating pictures if you can do that.
The horizon is not in complete darkness. Most of the time it has a slight blue ring at the limb of the Earth, in addition to the air glow being visible 100 kilometers up. Marshall, say what?
Go ahead.
Roger, Bill. Quick question here. We've got a TV-22 set up coming up starting about 3:35 for the following night's operations. What do you guys want? Do you want just some interior scenes of the module to show Owen and me working at either CPAC MTV and the image intensifier or what?
Yes.
We got some fluid physics module work out of it too.
Okay, we copy that. That'll be great.
Space Lab Houston on air to ground 1.
And Houston?
Yeah, in regards to that high data rate recorder, we just want to tell you that if you get a Space Lab 214 comm message, we want you to check the limit. Make sure that on that high data rate motor current, make sure it's not greater than 2.5 amps. If it is, we would like you to power it off. And we're about 30 seconds to LOS. And we'll see you again through TDRS at 4+0030.
Space operations.
Loud and clear, Mike. How do you read, over?
We read you loud, Byron. How are things on board?
Well, the good news is I've got the IHF going again. That happened at just a few minutes ago at 3:28. So it's just been 4 minutes since it started. As you probably know, we have the GHF ops light flashing, and I see that's coming up in about 3 or 4 hours to do another sample change there. We got TV22 set up, and I'm sitting here in the fluid physics module with another leakage of the fluid. When I got out to 15.4 millimeters separation, the thing got over the edge again, and I've just sucked it up, and I'm about ready to clean it up, and wait further instructions, over.
Okay, Byron, we copy that you got the IHF again at 3 hours 28 minutes, that the GHF, or is that gradient mode ops light is flashing, that you have 22 set up, and that you're doing FPM and had a fluid jump over again.
On the IHF, the grad ops light is on steady now. I was able to put the connectors on and get it started, so that's what that time was for.
Oh, that's terrific. What we're doing here is reprocessing sample number 325.
I understand. I wonder if it had something to do with the fact that there's no convection up here, the reason it got too hot.
That's very possible. We have a lot of thermocouple temperature traces and readouts and are kind of puzzled by that, but we're going to try this again. This is, I believe, the highest temperature of any of our samples, and so we are sort of stressing the system a little bit, but we're going to try this run again and get a lot of good engineering data.
Roger. Just a couple of comments. If we ever fly the FPM again, or when we do on D1, I would really suggest that somehow we figure out how to operate this thing out of the rack, and secondly, somehow figure out a way to make the travel of the carriage with the reservoir on it much smoother, because every time you pull it out, you have that big click clunk at the end of it, the liquid just sprays all over the place, and when you put it in, there's some sort of friction at the far end, and it's extremely difficult to get it in and out smoothly without throwing this fluid all over.
Yeah, I understand. Evidently, when you start the carriage to pull it back out, the jerk is what upsets the column. Is that right?
Oh, no, this is after the column's even been, you've got all the liquid back in. I'm just talking about even having liquid sitting right at the front of the feeding end plate there. We filled it up to the front of it. Just any little bit of motion will cause that liquid to break loose and go flying all over the chamber. So every time when I either try and open the chamber or close the chamber, the fluid just goes bananas. It goes everywhere.
I see. Are you using the 5 centistokes?
Firm. And I'm in the process now. I'm backing out the chamber. I suggest that we try some anti-spreading fluid or anti-spreading compound on that rear disc. The front disc seems to be holding the column reasonably okay.
Okay, good. Yeah, let me check with 300. That sounds like a good idea. By the way, have you been instructed in how to use that anti-spreading compound?
Not the stuff in the tube, no. The only instructions we had was for the little metal container of it for Madame Rodot's device.
Okay, we're about to go LOS, Byron, but we'll pick you up again in 13 minutes.
Okay.
And Space Lab, we have live TV from the Space Shuttle, and we're looking at the Earth.
Okay, sounds good, Bill. And you guys want us to turn our TV camera on out here also?
No. We don't, Byron.
Space Lab 1, this is Marshall Operations for Byron or Owen.
Go ahead, Michael.
Yeah, right. Hey, we have a game plan for this upcoming nighttime pass. Yeah, we have a game plan here, guys, for this upcoming nighttime pass. We'll be using CPAC's MTV in the manual mode, as we did last night. And because the experiment is, the only active experiment that we'll be running is PICPAB, we have actually two parts of the night that we need to discuss. During the first part of the night, from sunset until 4 hours, 34 minutes, the CPAC people would be delighted if you could pan around the orbiter and look for signs of vehicle glow. And you're free to do that manually with whatever you'd like on the panel. But starting at about 4 hours and 35 minutes, PICPAB will come on. It'll start its warm-up, and at 4 hours 43 minutes, the E-gun is going to be active. That's going to be a 4-minute period. They're particularly interested in getting some MTV images of their own experiment in operation. The coordinates of the 020 E-gun are very close to the stowed coordinates of the MTV on the Romeo 5 Juliet panel. That's an azimuth 180 and a COL plus 90. You also have 13 minutes of tape available on VTR2 on which to record MTV images. Anything that's visually interesting, you're urged to record. And of course, we'd like to see some of the E-beam activity from the active phase of the PICPAB experiment. And you can start and stop the recorder whenever you'd like.
Okay, very good. I got a good copy on all that, Mike. And I have a question on your TV-22. You guys going to put that on recorder 1?
Stand by. Okay, the DMC is not quite approved that yet. I think we'd originally set that up for VITR number 2, but perhaps we can move that to VITR number 1 if you like. Just a minute.
It doesn't matter to me, but my PCAP shows that TV-22 going on VTR number 1. You guys changed it?
Yeah, stand by a sec. We're looking into that. Space Lab, this is Marshall Ops. Yeah, you're go to put that MTV data on VIT number 1. That'll be fine.
Okay, Mike, I guess we had a little mix-up there. I was just trying to confirm on the TV-22 ops, which is a joint ops thing, that you guys were going to be handling that. And I'll put the MTV anywhere you want it. It doesn't matter to me.
Okay, I see. TV-22 setup. Could you remind me what that is?
It's a joint ops with CPAC and API.
Yeah, okay.
Houston, this is Space Lab on Underground 1, over.
Repeat.
The call for the Moker, Houston, on Underground 1.
Say again, Space Lab, this is Houston.
Yes, Houston, I just wanted to let you know we took a look at the HDR motor current, which is only 0.8 amperes. And I sort of missed what you were saying as you went over the hill, but I believe that's satisfactory. We left the HDR running. Is that what you wanted, over?
That's affirmative, Owen. What we were trying to tell you is that we just want you to watch those currents, and if it goes out of limits high, we'd like you to mode the recorder to stop.
Okay, and what is the upper limit?
2.5.
Yeah, we don't have... And Space Lab, this is Marshall Ops. We have you for about 35 minutes.
Hey, Bill, I'm good.
And CPAC is standing by on the line.
Yeah, Marshall Ops, Space Lab.
Go ahead, Byron.
Hey, Bill, we got tape recorder number 1 in record, and I guess Bruce is shipping us down some videos, so we should be having our TV-22 activities. And what I'd like you guys to do, if you can configure it for the MTV to go over to whatever recorder you want to put it on recorder 2, I guess Mike said earlier, and you'll be able to catch us as we start the CPAC MTV operations.
Okay, we copy that, and we'll try to put that in work.
Okay, and I've got the camera on down here, and Bruce has got his on up there, and you guys got control of it, okay?
That's affirmative.
We think that's affirmative. We're having a little POC problem here right now. Just a minute.
Byron, we've lost our data. We've got a 370 problem.
Okay, I guess we got it then, huh?
I guess it's your show.
We'll do the best we can. No.
Byron, we're going to have to apologize. We accidentally sent up a time execute command, which is what started VTR1 going to record. What we had really intended is that you handle the recorders on this TV-22 run and also on the CPAC MTV data, because that's, of course, where you're looking for interesting shuttle glow phenomena for 10 minutes, and then, of course, trying to find the 020 beam.
Roger, we copy all that, Mike, and we're doing that right now. In fact, I started the tape recorder, and Brewster should be shipping me down some video, so in about another minute or two, I'll go ahead and re-switch it to our camera, and you'll get some of our data down here.
Real good, Byron. Thanks a lot.
Okay, we're now recording some TV from the Space Lab module.
Okay.
It looks like we've got TV set up for tape recorder 2. That looks great. And Mike, maybe you guys can tell us how much time you want on this recorder number 1 for the TV-22 ops, because we're obviously out of sync with the standard tape recorder plan.
Okay, right now we're looking up to You can go as far as 23 minutes time remaining as part of your TV-22 ops.
I've got 13 minutes to do this for the MTV operations on recorder number 2, right?
That's correct. We have 13 allocated.
Right, got a good copy.
Oh, Byron, Will wants the MTV data on VTR number 1.
Well, so we switch the vid then. And Marshal Ops, we've got the FDM still rolled out, and I cleaned up my last overspread, and I guess we're standing by awaiting any further instructions here on the fluid physics module from Isidoro.
Right. In fact, we have John Paday standing by, and he'd like to give you a little briefing on the use of anti-spread compounds in an effort to try and make sure that additional fluid columns don't spill over the edge of their assigned radii on the plates. If you'd like to talk to him, I believe he's even enabled right now, and I don't believe we have a lot of traffic to go up. Is that right, Bill?
I am enabled. John Paday here, Byron.
Oh, John, you're loud and clear.
Okay. Now, very quickly, first of all, how much liquid is being lost in all this work?
Oh, I'd say good bit. I'd say we probably lost on the order of, let me think.
And Byron, we may, when it gets to be nightfall, which should be pretty soon, we'd like you to start this MTV action. So maybe you ought to hold off on the fluid physics business until a little later.
That's a good idea. Stand by, John. I'll catch you later.
Okay.
And Space Lab, this is Marshal Ops for Byron. We're willing to change your VAS for you for MTV if you're done with TV-22.
Okay, no, I've already done it, Mike. Thanks anyway.
Okay, yeah, I see on the scratch pad line you've taken care of it. Thanks a lot.
Marshal Ops, Space Lab.
Go ahead.
Roger, I show us have about 28 minutes remaining on VTR number 1. With my 13 minutes of operation on the MTV, that leaves 15 minutes left. Do you guys have anything planned for that other 15 minutes?
We're checking, Byron, just a second.
I need to know what API is going to run.
Byron, that's the tail on that tape. The final 15 minutes had been reserved for AEPI operations, but we're not sure, if we're going to be putting much more on there. So we're going to check with those people and see what the fate of the end of that tape is going to be.
Okay, real good. Appreciate it. Okay, Marshal Ops, Space Lab for the 02 people, 03 PIs.
Byron, they're listening in. I don't believe they're enabled yet. Okay, they are enabled, Byron.
Okay, well, I'll just give them some here. We've got the tape recorder on, and we're getting some good airglow here. Looks very nice.
That's terrific. Our displays, I'm afraid, have gone static. When the last we saw, you had experiment 03 POCC data routed to VTR number 1 and number 1 in record. Of course, what we want to capture is the 02 MTV data, item 4.
I did item 4. Bye.
Okay. And Byron, we've looked into the data management. You can use all the tape on this reel except for the final 8 minutes.
Okay, copy. All but 8 minutes. Mike, I've got item 4 recorded, set to both of them.
Okay, that's great. It's just that our displays have quit updating for the time being, so we're looking at what is probably old data. Thanks a lot.
Roger. And it's a very nice band. You can really see a nice airglow, nice stars. I'll tell you one thing, though, for future reference, Mike, joystick sure would help on these rather than 2 controls. It's like your analogy of trying to drive a truck by controlling each wheel separately.
Could you say that again, please, Brian? I didn't capture all your sentence.
Okay, I said that I'm able to sweep the horizon quite nicely here, but like trying to drive a truck using each wheel independently. It's really nice to have a joystick on this.
Boy, it sure would. Those separate knobs just aren't a very convenient way to control something like a camera, are they?
At all.
Have you noticed that the MTV drives are slow in their action? The other crew had been mentioning that.
Oh yeah, it's about like we practice in Japan. It just takes a while to get used to it.
Yeah, okay, we copy. How's the image quality look?
It's quite nice, actually. You can see the stars, cities on the ground, a definite band of air glow here. It's real nice.
Byron, this is experiment 3. Are you running API, and is that ON? I thought that's what you said a few minutes ago.
No, Steve, the only thing we've got now is the CPAC MTV out, and we're looking at air glow kind of sweeping along the horizon.
Okay, that's what we expected. I misheard what you said. Is Owen in the orbiter, or is he in Space Lab?
Here in Space Lab, and he's using the image at Star. Now we've got some lightning and a few thruster firings. It's all lightning.
Okay, I copy.
How soon is it going to be, Brewster? Okay. Okay. Give me an idea. Brewster, can you see the horizon out there? Yeah, I've got it. It's push forward about 2 degrees down from the local vertical. Got the right front window.
Space Lab, this is CPAC on air to ground 1 for Byron.
Roger, go ahead, CPAC, loud and clear.
Are you about ready to move the MTV over towards the ESA-20 electron emitter?
That's firm, yeah, they're firing at 4:43, 6 or 7 minutes from now. We're still getting a very good air glow. I said the ESA-20 beam will be firing in about 6 minutes, so we're all set up for that, or will be. We're getting good air glow from all around the horizon from end to end.
Byron, we have 2 minutes.
Okay, our PCAP shows 4:3.
You're right, I just got corrected.
Thanks, Peter.
Space Lab, CPAC on air to ground 1 for Byron.
Yep.
How's your air glow doing?
Oh, okay, I've got the horizon now.
This is experiment 3 for Space Lab. You are going to come up to this electron gun event in a few minutes. I hope Owen is ready to take those pictures.
Sure, he's ready, Steve, no problem.
And Byron?
Up there looking at the minus Z-axis. Up there looking at the minus Z-axis, Steve.
Great, thank you, thank you.
And Byron, you should probably be swinging the camera, the MTV camera, over to the ESA-20 beam.
Okay, we're pretty close. It has us at 180 and a total hour about 60 now, and I can just get the horizon here.
Say again, please, Byron.
Roger said I'm very close to where we need to be pointing, and I've still got the horizon in view, so we're okay.
Very good.
And Byron, you can turn that VTR on if you like, all the way from now till sunrise, which is only about 7 minutes in the future. You still have plenty of tape left.
All right,
You have it, I see.
I have it, yep, thank you.
Space Lab, this is CPAC on air to ground 1 for Byron. Do you see the beam? It should be coming in about 10 seconds.
Okay, stand by. Pointing the right spot. I don't see anything yet. There's a first calibration block.
Yeah, that's an affirm, Byron. All of the modules begin with a calibration as part of the startup block.
Right. I wish we had a focus on this.
Copy.
He said the gun is right at 180 and plus 90, right?
Right. Looking up,
Okay, I'm looking there.
looking just over the top of Appy's gimbal.
I think that's a little left of 180.
That's right.
I don't see anything yet. Bill, can you give us a call when the gun really fires? We don't see anything yet. I've got the Appy gimbals right here, and I'm going just over top of it.
Okay, Byron, thanks for that report. I'm afraid we're not being able to flow any data on the progress of Experiment 20, so we can't tell you down here how that experiment's running. You'll probably be the first to know.
Well, I see the electron gun is on, and the block number 5 is going away, and the cup is running, but I don't see anything here. A very nice, clear TV picture of the aft end Kona Space Lab, with a little bit of horizon and air glow in the background.
Okay, thanks very much. Byron, we have a suggestion from the 20 team. In the minute or two that remains before sunrise, you might try panning the camera vertically upward towards smaller co-elevations to try and see if you can see a faint ribbon of light extending off into the distance.
Michael, you read my mind. I just went to a co-ele about 0 to try and look straight down and see what we get.
This is CPAC. Very good move, ESA 20 and Byron.
I don't see anything.
Copy.
Just saw something flash.
Copy. And Byron, you should be going into the MTV off sequence now.
I understand. You're going to go MTV off.
This is Experiment 3 Space Lab. Supposedly the beam firing has ended, so I don't know whether there's not much point looking anymore on.
No, there's enough light on my window now that that makes it too bright to be seen, Steve. So I never saw any indication of any picked up firing along the -C axis.
Thanks, Byron. For
Get some air glow pictures a little. Get some earlier air glow grading pictures earlier in the nighttime, however. Okay, we've got the MTV power down now.
Real good, fellas. Thanks for a good one. We appreciate that, and I guess, gee, we still have 11 minutes tape left on that recorder.
Sure.
And Owen, if you did not perform experiment 25 earlier today, Dr. Helen Ross would certainly appreciate it if you could get it in this free time that you have coming up.
And it has already been completed and filed. Bill, it has already been completed, on schedule, and filed.
Roger that. And Byron, if you could, before we go LOS, quickly give us a status on the material.
Okay, Bill, a quick one. The IHF is in the gradient ops mode, and I don't know how long this runs, but probably be an hour or two. CHF ops is flashing, HTT ops is flashing. Everything else looks okay, and the fluid physics module is sitting here powered down. I'm awaiting instructions from the FPMPIs, over.
Okay, we copy that, and the 300 people, thank you very much.
And when you get back, the next time, I'd like to sit on that day about his animals.
And Space Lab, we've got you for about 1 more minute, and we'll see you at Aurora Valley at about 5+05 for a short pass.
Okay, Bill. Sounds good. And if you can have John up and ready to go, I'll try and talk to him.
Okay, I'd like to enable John at about 5+34. We have about 10 minutes he can talk to you.
Okay, very good. And what do you guys have in the last 8 minutes on the tape recorder? Is that for another run coming up here in the next hour, a little after 6 o'clock?
We'll catch you next pass.
Yeah, that's for an API run that's coming up. Experiment 3, they're going to be running soon.
Okay.
This is Marshal Ops over Aurora Valley. We'll have you for about 1 minute and 45 seconds.
Hey, Bill. So I'm clear, Bill. And I've got another column built here, and it's kept it concave all the way out for Isidoro. And it's hard to tell, but I think it may have spread over the feeding end plate just a little bit. But it's still concave, and I've got a setting of 22.4 and 17.6. That's front plate and reservoir, respectively.
Okay, thank you, Byron. And Space Lab, we'll see in about 26 minutes with S-band at about 5 plus 34.
Further copy.
Space Lab 1, this is Marshal Ops with you. How do you copy?
Roger, you got your line and clear, Mike.
Hey, real good, Byron. We have some information about this evening's joint run of the CPAC MTV and API and Experiment 20, if you're ready to copy.
Okay, I'm ready to copy it. If you want to go ahead and give it to me, Mike.
Yeah, real good, Owen. The plan for this orbit is to route API information from the 03 experiment to VITR number 1. You'll find there's 10 minutes of tape there, and you're welcome to use all of it when we get API up and running in the second half of the evening. And we're also using MTV of the CPAC experiment. You can route that to VITR number 2, and you're welcome to use as much as 15 minutes of tape on that recorder if you like. We can take care of the routing from here, I'm told. We now have command capability. We would like you, though, to manage the start and stop of the recordings, simply because you'll know when there's something interesting to see. We'll also be running Experiment 20, PICPAB, in its active mode. And what we'd like you to do, if possible, when Experiment 20 starts operating actively, is to search around a little bit with the MTV in its manual mode as before, and again, see if you can see any evidence of the electron beam.
Okay, we understand that.
We also have some messages for either one of you who's got a little bit of time from Marcia Torr. She needs some work done on Experiment 1, which involves marking up her malfunction 1.7 from the 01 flight data file, page mal-9. If one of you can copy down some changes and run this mal for us, we'd appreciate it.
Okay, we ought to get started on the setup here before long. If they're short, why go ahead with them?
Yeah, I think that's probably best that you get started with the manual CPAC MTV operations, and then when you have a minute and let me know, I can read up this the work to do on this MAL 001.
Okay, let's see. Byron's going to copy what he says here for you. Give me a minute.
And we also have John Paday standing by who'd like to talk for Byron at whichever point he might have 5 minutes available. He has some advice on using the anti-spread compound on the FPM.
Okay, that sounds good, Mike. You prioritize whether you want the API stuff or the ISO stuff copied first or FPM.
Yeah, let's do the ISO first because there are a couple of time-critical steps in that. Okay, Byron? Great. I'd like you to turn to ISO page mal-9er. That's malfunction 1.7, manual turn-on and ops. Marcia's devised a workaround for the potential problem involving Row 21. If you're ready to copy, I have a few changes I'd like you to make to that mal, and then I'm going to ask you to run it sometime tonight. Right. At step number 2, where there's a long string of issue multiple commands, we want you to run that box only if Row 21 equals Oscar Papa. If the row is Nancy Oscar Papa, we don't want you to do that box. Got it?
Got it.
And on step 3, we want you to emit that. You needn't check the cooler power light. We're able to see some data here. Right below step 3, you can cross out the step that says after 15 minutes because we know that the detectors are already cooled down, so you needn't wait any time there. In step 4, the first of the 3 lines, we want you to do only if Row 21 equals Oscar Papa. Again, so just like in box number 2. And, okay, and finally, in box number 6, the FO select which we want you to key in when you get to box 6 is XX equals 14, YY equals 87.
Okay, what time do you want that done at?
Real good. You can key those in any time from now up until about 45 minutes from now. That is to say, you can run this manual turn-on. No problem whenever it's convenient. But we do have a critical start time to put in at box 7. We want you to start at box 7 no earlier than 0630 and no later than 0639. That'll start that FO running in concordance with our present attitude timeline.
Okay, copy.
Real good, Byron, and you're welcome to go do that anytime you can fit it in tonight. I realize you have a fairly busy night.
Marshal Ops, Space Ops.
Go ahead, Byron.
Okay, Bill, it's for Mike, really. We just pulled up the DPM display, and Route 21 is NOP, Nancy Oscar Papa.
That's the configuration it should be in, Byron.
That's the configuration we expected, Byron, and that means you don't have to send those issue multiples. Those multiples power up various subsystems of ISO, and with the row being Nancy Oscar Papa, those commands have already been taken care of. That is to say, ISO has been powered up. So you can just skip that step in box 2, and you can also skip the first line in box 4. You should, however, do the second line and the third line in box 4. It's important to remember those.
Okay.
And Byron, we had one other comment on this MAL 1.7. In box 8, delete that MAL 1.8. We will not be going there since we won't be running additional FOs in this particular run. Just leave it in manual, says Marcia.
Okay, I understand. Leave it in manual.
Real good, Byron. And now I understand we have John Paday standing by who'd like to talk to you a little bit about anti-spread compounds if you have time.
Okay, I just completed block 5, Michael, and the FO's running, so give me 1 second to reorganize my paperwork and I'll be ready for John.
Terrific. We appreciate your help on that. Thanks a lot.